Welcome back to the session. In this session, we are going to apply machine learning. And before we apply machine learning, we have to do some necessary imports. So as you can see over here, these are all our imports and we are going to use on this particular data frame now. So these are the models that we are going to use now and these are the evaluation matrix. So you can see that we have imported pre-processing from sklearn. We have imported feature selection, that is select from model. Apart from these imports, you can also see that we have imported train test split. So this train test split, it will help us to divide our data into training and testing parts. And we basically split our data into two parts. One is called as training part, with which we are training our model. And then we have another part called testing. So it is done with the help of this import called train test split. And after that, from the model selection, we have imported k-fold and cross-validation score. So when it comes to the cross-validation, it is nothing but a resampling procedure that is used to evaluate machine learning models on a limited data sample. And the other import over here are evaluation matrices, which will decide how well our models are performing. Over here, we have used logistic regression, KNN model, multinomial Bernoulli-Naivy Bayes, support vector machine, and the random forest classifier. So all these models are going to get evaluated with the help of evaluation matrix, that is the F1 score. And the other evaluation matrix here are recall score, precision recall curve, F1 beta score, and confusion matrix. So let us go ahead and see what this F1 score tell us about. So this F1 score is an evaluation matrix that will tell us how good our model is performing. And F1 score is nothing but a measure which tells us to convey the balance between decision and recall. And after that, we have a recall score over here. So when it comes to recall, a recall is the ability of the classifier to find the positive samples. When it comes to recall, the best value is 1 and the worst value is 0. And apart from this, we have another important evaluation matrix which is called as a confusion matrix. It will tell us how many predictions were classified correctly or how many predictions were classified incorrectly. So this is another evaluation matrix which is a very good in order to classify and evaluate how well our model is performing. The next import is ROC, an accuracy curve, which is called as the area under the curve. And next one is our machine learning models. So we have our first machine learning model as a logistic regression. So logistic regression is used to describe the data and to explain the relationship between one dependent binary variable and one or more nominal or ordinal intervals. And the other model that we have imported is k-nearest neighbor, also called as KNN. So the KNN algorithm is said to be one of the most simple classification algorithm and it is one of the most used learning algorithm. This KNN is also sometimes called as non-parametric, and apart from these two models we are using Naivy Bayes model. So this classifier is the collection of classification algorithms that are based on Bayes theorem. So it is not a single algorithm but a family of algorithms where all of them share the common principle. That is, every pair of features being classified is independent to each other. And then we have used a support vector machine. So support vector machine are nothing but it is called as a supervised machine learning algorithm which can be used for classification and regression use cases. Also, the machines perform well on classification as well as regression cases. And however, it is highly used for classification problems. And after that, we have a random forest classifier. So when it comes to random forest classifier, the random forest is an open machine learning algorithm which can be used for a variety of tasks including regression and classification. So basically the random forest classifier is an ensemble method. That means the random forest is made up of a large number of small decision trees. So this is also nothing but the collection of small decision trees. And then we have imported count vectorizer and TF-ID vectorizer over here. So the count vectorizer provides a simple way to both tokenize the collection of text documents and build a vocabulary of known words, and also to enter new words using this vocabulary. And then we have a TF-ID vectorizer, where TF-IDF is an abbreviation for the term frequently inverse document frequency, and this is a very common algorithm to transform text into a meaningful representation of numbers, which is used to fit machine learning for our prediction. And then we have imported n-gram, bigram, and trigram. Now let us input all these required models. So yes, we are done with all importing session. So now we have defined the data frame, label, vectorizer and n-gram. And then we have split our data into dependent and independent variables. Over here we have used train test split and we have split the data into independent and dependent columns. So we have given a test size as 0.3, that is, it means that from the entire data set, around 70% of data is going to reduced for train purpose and 30% of data is going to reduced for the test purpose. And we have used the random state as 50. Here we have used vectorizer and we have used a vectorizer on X train and X test data set. And here we have used convectorizer and we have used convectorizer on X train and X test, and you can see that we have all the machine learning models over here. So like we imported logistic regression and then we fit the model on X train which was on the X test and on the Y train, and then we have used k nearest neighbor, and then we have fit the KNN model on X train and convectorizer on Y train. And then over here we used Bernoulli-Navy Bayes, and then the same thing has been done, that is we have fit the model on X train CV1 on Y train, and the same is done with the multinomial NB, similarly with the support vector machine and random forest, and the random forest classifier fit on X train and CV1 on Y train. And over here as you can see we have used F1 score as our evaluation matrix, and we have used this F1 score on the X test. So basically we are going to use this F1 score to evaluate how all these models are going to perform. And F1 score is also called as F1 measure, which conveys the balance between precision and recall.